question at hand concerns the use of Unistrut to support outdoor fiber optic network communications cabling on a building's roof and whether its use complies with electrical codes. Specifically, can the Unistrut be viewed as a support mechanism or must it be classified as a raceway, requiring it to be listed? Article 770.113 directly addresses outdoor communications cables, stating that these cables shall be listed and installed according to the listing requirements and any manufacturer's instructions. This article places the onus on the cable itself to meet certain standards when used outdoors. Article 384.6 pertains to raceways, stating that raceways, other than metal raceways, must be listed for the purposes of Article 725, which covers remote control, signaling, and power-limited circuits. Given these stipulations, the critical distinction lies in whether the Unistrut is acting as a raceway or simply as a support structure. In this scenario, the Unistrut is primarily functioning as a support mechanism for the outdoor communications cables. It is providing physical support and organization, but it is not completely enclosing the cables in the manner that a traditional raceway would. Therefore, it is not necessarily required to be listed as a raceway. However, there are several factors and considerations to ensure that the installation meets safety standards and best practices. Firstly, the cables must be suitable for outdoor use, meaning they should be listed for outdoor applications. This includes resistance to sunlight, moisture, and temperature variations typical of the northern Illinois climate. Secondly, the method of securing the cables to the Unistrut should not damage the cable's jacket or impair its performance. Using appropriate cable ties or clamps designed for outdoor use is recommended. Thirdly, the Unistrut itself should be properly grounded if it is made of metal. This is to prevent any potential electrical hazards. The grounding should comply with Article 250, which covers grounding and bonding. Fourthly, the installation should adhere to any local codes or regulations that may be more stringent than the National Electrical Code, also known as NEC. Local authorities may have specific requirements for cable installations on rooftops. Fifthly, consider the mechanical protection afforded by the Unistrut. While it may not be a listed raceway, it should still provide adequate protection against physical damage to the cables. Evaluate the risk of impact or abrasion in the specific location and ensure the Unistrut provides sufficient protection. Sixthly, review the manufacturer's instructions for both the cables and the Unistrut. The manufacturer may provide specific recommendations for installation and support. Seventhly, ensure proper spacing and support intervals for the cables along the Unistrut to prevent sagging or strain. The spacing should comply with the cable manufacturer's recommendations. Eighthly, address any potential issues related to ice and snow accumulation. In northern Illinois, ice and snow can add significant weight to the cables and the support structure. The Unistrut and its support should be able to withstand these loads. Ninthly, consider the potential for wind loading on the cables and the Unistrut. High winds can exert significant force on the installation, so it should be designed to withstand these forces. Tenthly, examine the overall aesthetics of the installation. While functionality is paramount, a neat and professional installation is always preferable. The cable should be organized and supported in a way that minimizes visual clutter. 11thly, document the installation thoroughly, including photographs and drawings. This will be helpful for future maintenance and inspections. 12thly, inspect the installation periodically to ensure that it remains in good condition. Look for any signs of damage, wear, or corrosion. 13thly, make sure all components used, such as fasteners and supports, are corrosion resistant and suitable for outdoor use. Stainless steel or galvanized materials are often preferred. 14thly, if the Unistrut is supporting multiple cables, ensure that the total weight of the cables does not exceed the load capacity of the Unistrut. Check the manufacturer's specifications for load ratings. 15thly, when running cables across the roof, ensure that they do not create a tripping hazard or obstruct access to equipment. Maintain adequate clearances around walkways and equipment. 16thly, if the cables are exposed to direct sunlight, use UV-resistant cables and cable ties to prevent degradation. Sunlight can damage some cable jackets over time. 17thly, if the cables are routed near any HVAC equipment or other sources of heat, ensure that they are rated for the appropriate temperature. High temperatures can also damage cables. 18thly, if the cables are routed near any sharp edges or corners, protect them with appropriate edge protectors or conduits to prevent abrasion. 19thly, if the Unistrut is attached to the building's structure, ensure that the attachment method is appropriate and does not damage the building's roof or walls. Use proper anchors and fasteners. 20thly, if the installation involves penetrating the building's roof or walls, ensure that the penetrations are properly sealed to prevent water leakage. Use appropriate sealant and flashing. 21stly, consider the potential for future expansion. If you anticipate adding more cables in the future, ensure that the Unistrut has sufficient capacity to accommodate them. 22ndly, if the cables are carrying sensitive data, consider the potential for electromagnetic interference. Shielded cables may be necessary in some cases. 23rdly, if the cables are routed near any electrical power lines, maintain adequate clearances to prevent electrical hazards. Consult with a qualified electrician to determine the appropriate clearances. 24thly, if the cables are routed near any lightning rods, ensure that they are properly grounded to prevent damage from lightning strikes. 25thly, if the installation is located in an area that is prone to vandalism, consider using tamper-resistant fasteners and enclosures to protect the cables. 26thly, if the cables are routed near any trees or vegetation, ensure that they are not damaged by branches or roots. Trim any overhanging branches. 27thly, if the cables are routed near any bodies of water, ensure that they are protected from moisture and corrosion. Use waterproof connectors and enclosures. 28thly, if the installation is located in an area that is subject to extreme weather conditions such as hurricanes or tornadoes, ensure that it is designed to withstand these conditions. Consult with a structural engineer for guidance. 29thly, if the cables are routed near any hazardous materials, ensure that they are protected from exposure to these materials. Use chemical-resistant cables and enclosures. 30thly, if the installation is located in a confined space, ensure that it is properly ventilated to prevent the buildup of heat or fumes. 31stly, if the cables are routed near any sources of vibration, ensure that they are supported in a way that minimizes vibration. Use vibration dampening mounts. 32ndly, if the cables are routed near any sources of noise, ensure that they are shielded to prevent noise interference. Use shielded cables and enclosures. 33rdly, if the installation is located in an area that is subject to seismic activity, ensure that it is designed to withstand earthquakes. Consult with a structural engineer for guidance. 34thly, if the cables are routed near any sources of radiation, ensure that they are shielded to prevent radiation damage. Use radiation-resistant cables and enclosures. 35thly, if the installation is located in an area that is subject to extreme temperatures, ensure that the cables are rated for the appropriate temperature range. Use high temperature or low temperature cables as needed. 36thly, if the cables are routed near any sources of corrosive chemicals, ensure that they are protected from corrosion. Use corrosion-resistant cables and enclosures. 37thly, if the installation is located in an area that is subject to high humidity, ensure that the cables are protected from moisture. Use waterproof cables and enclosures. 38thly, if the cables are routed near any sources of electromagnetic fields, ensure that they are shielded to prevent interference. Use shielded cables and enclosures. 39thly, if the installation is located in an area that is subject to static electricity, ensure that the cables are grounded to prevent static discharge. 40thly, consider the long-term maintenance requirements of the installation. Ensure that the cables and the Unistrut are accessible for inspection and repair. 41stly, ensure that the installation complies with all applicable safety regulations. Consult with a qualified electrician or engineer to ensure compliance. 42ndly, it is advisable to consult with the local electrical inspector to obtain their interpretation of the code and to ensure that the installation meets their requirement. In summary, while Unistrut can be used as a support mechanism for outdoor communications cables without necessarily being listed as a raceway, careful attention must be paid to the suitability of the cables for outdoor use, the method of securing the cables, grounding, local codes, mechanical protection, manufacturer's instructions, spacing, environmental factors, aesthetics, documentation, and maintenance. Adhering to these considerations will ensure a safe and compliant installation.